In computer networks or networking, the word which will be often used is packets. You will be hearing it a lot. What is the meaning of packet? What is the formation and example? So what does packet means in a network? So in order to understand, just have an analogy with the postal letter. So whenever you write a letter, say to your friend, then you write the content, there will be a sender address, there will be a from address, that is the sender and the receiver both will have the address. This kind of formation, actually the word packet has come up. Now Donald Davis, he actually coined this word, and that previously it was not being thought that packet will be so helpful. There is a concept, but now everywhere we have packets. So we have a postal letter, envelope can be called as a packet. So in a computing environment, in a networking environment, packets are the basic units of communication over a TCP IP. So we have 1 centimeter, 1 millimeter, 1 milligram. There are certain units. Here also we can have an analogy again with the communication over the network between the source and the destination. The network packet or IP packet or simply the datagram. You may be asked what will be the size. MTU is also there. So what is the normal size of a IP packet? So there is no fixed size, but you can give a size around 1500 bytes. This is the typical packet size. That is why we call it as a unit of data, because it is traveling now. So when it is traveling on an internet, on a network between sender and receiver, then the unit of data can be called as, say, from 1 kilobit per second to 1.5 kilobit per second. Because now it is moving, it is traveling. If you have a static, you can call it as the size can be this one, around 1500 bytes. That is why it is called packet switch network, because the packets are moving from one place to another, from one device to another. And devices on the TCP IP network will do what? Because packet has no fixed size. It depends totally on the bandwidth. It depends totally on the available say network, whether it is fixed, the width is fixed or it is varying. So what will happen here is that there is a packet, or you can say that it is an information. The data has to go from one place to another, but there is a congestion or the bandwidth limitation. So the network can accommodate various bandwidth, since the packets can be divided or the content can be divided into small pieces. So when we divide the content into different pieces, these pieces are nothing but the packets. And this can take multiple routes. One can go like this, one can go like this, the other can take some other path. So these 1, 2, 3 which I am naming, this is the multiple route. They will take a multiple route to the source, to the destination. One more thing, there may be a loss of packet, so it can be transmitted. So there are certain benefits of packets. Packets can be routed through different path, as I just told you. That is why it is called as packet switching, because packet is going from one place to another. It can take different route, different path, depending upon the congestion of the network, depending upon the available bandwidth of the network. So there are so many things involved. That is how the packet can be routed. And this kind of network is called packet switching. As I told you that this packet can be stored and this can be retransmitted also. If there is certain error, say the receiver comes up with an intuition, oh, the message is not good, it can be retransmitted. So there can be, if there are certain damaged packets or congested part of the network, or even the network can be damaged, it can be broken. So packets can be rerouted also. And the most important part is the security. Every packet can be given encryption, which will be decrypted on the receiver side. Now here is a man, he has some stuff. He wants to take it, but he is not able to. Why? Because the size is very high as compared to the capacity of the truck. So what are the packets? Packets are nothing but the envelope. That is the data you are transferring from sender to receiver. You are using the TCP IP network, and these packets or these envelopes or these content are sent according to the network bandwidth, and there are so many things involved. That is, this is the content as I just told you. Now this, you can consider this as a whole data, whole content. But before the file is sent across the internet or a network, that is using the TCP IP, it must be broken down or divided into series of packets. So this is the data. The packet will be formed when you divide it according to the requirement. So packets are essentially, these are the smaller parts or chunks of a larger file, and they will be transmitted individually. For example, this is an image and this is very large. You cannot send it at once. So you have to divide this into different pieces. This is how we divide it. This particular data in this example, we have divided it into say 291 separate sections or pieces, and these 291 are nothing but the packets, and this will be transmitted from sender to receiver. But it depends on the network. The network can have different bandwidth. So this, you may have say 100 packets, you may have 500 packets. So it is not fixed that you have to do 291 also. That's what I am trying to highlight here. A packet is simply a content which has to go from sender to receiver. And every packet is organized normally, typically into 3 sections, 3 parts. We call it as IP, we call it as a datagram. So the first part of the data packet structure is header, second is payload, and third is trailer. So this header contains instructions about the data being carried out by the packet. So these instructions include various things. For example, length of packet. Because some networks have fixed length packets while others rely on the header to contain this information. Right? So in the header only you can have length of packet. Along with this, we have the synchronization. A few bits that help the packet match up to the network. So synchronization also is given here in this first part, which is the header. Packet number, which packet this is in a sequence of packets. So packet number will be also there. Then you have a protocol, because on networks that carry multiple types of information, the protocol defines what type of packet is being transmitted. Email, web page, streaming video. Then the destination address where the packet is going, originating address where the packet came from, right? This all is under header. Then we have the payload. This is also called as the body or data of the packet. This is the actual data that the packet is delivering to the destination. If a packet is fixed length, then the payload may be padded with blank information to make it the right size. So this is the example of a proper data actual going. So this is the padding. If the data is less, the padding can be done with the blank information. So this image, for example, this image which we discussed, this is the actual 1001 data that will go, and this will be under payload. The third part is the trailer. You can also call it as a footer. This typically contains a couple of bits that tell the receiving device that it has reached the end of the packet. And this trailer may also have some type of error checking. For example, the most common error checking used in packets is CRC, the cyclic redundancy check. So this will tell you how many bits are damaged, or they are not reached, or they are out of order. So these are 3 parts. Let us understand the packet, how it is transferred on a network from source to destination with an example. If you are using the TCP IP, using the packet switch network, because the packet is involved here. So this packet, how it is being formed, you can have a whole bunch of data, but the packet can only be sent depending upon the network, depending upon the congestion, depending upon the route available. Alright. So the different route can be taken. If the packet has to be retransmitted, it can be also done. So rerouting, packet retransmission, error, congestion, all these can be done or understood using the packet. So Donald Davis actually he coined this word packet. So if you want to send an email, let us take an example of packets email. So you want to send an email to a friend. Now let us understand that this email is around 3500 bits, or divided by 1000 you will get it as 3.5 kilobits. This is the size of the email you want to send. Now when we come to the packet, that is the packet concept, it is kind of an envelope that can go. So the network can send, for example, it says that we can only send the packet if you have the length of the packet as 1024 bits or 1 kilobit. So 1024, 3500 and 1024. So there is a difference. The content or the email is not of the size which the network want. So we have to divide this 3500 into parts. Those parts are nothing but the packets. So we have every part as host. Then we have trailer, this header, trailer and body. So the header will have the sender IP, receiver IP, the protocol being used, packet number, the synchronization bit, etc. Now if this size is say fixed 96, the trailer size is fixed as 32 bits. So 96, 32 and 896. If you add this, that is going to comprehend to the packet size. That is, you can have only 896 payload in one packet. Not more than that. So because if you add this, then you will get the size which is being discussed here. So this 3500 has to be divided into certain parts, or we call it as a packet, so that it can be sent along with the header and trailer included. So just take 3500 divided by 896, you will get a number that is around 3.9. So that is, you need 4 packets. So that is how this whole email will be divided into 4 packets. The header of each packet is 96 bit, trailer is 32 bit, and you have 896 for the payload. But this 896 into 4 is not giving you the actual size. That is, all the packets will not of the same size. So you have to do the padding also. So these are the four packets. First, second, third will have 896. The last one will have 812 bits. So 3 will contain 896 as the payload. The last one, the fourth one will be 812. That is how it is divided into 4 packets. Alright. So now the information is there in header. What is the receiver? What is the sender? All the information. Now these 4 packets will exactly go to the destination, and this packet will use the packet switching network of TCP/IP. So this is all about packets. Thank you so much. Take care of yourself.